Hello, my name is Gary Ellis, and I'm going to present the quick 5-minute overview of what this new image router is all about. So the motivation for this new clock router is in response to issues with Marco, which is our current clock router. And I won't go into all the details here, but just suffice it to say that at the heart of Marco is a maze router, and it can have trouble sometimes making connections, and if it fails to make this connection, it just drops the connection completely. So in the illustration at the top, there's too much congestion around the driver pin, and so it just drops the connection to the sink in the upper left-hand corner. And then when it does make these connections, it is a maze router, and so it tends to wander around a bit too much rather than making straight connections the way we'd like it to. As shown by these trunks in the bottom image, we'd like to see the trunks go straight out to all the spines much more directly. And then also, if the spines are not close enough to the sink pins, we can get too much wire wandering around on the 1x layers. So all this is to say that with the excessive wiring, the wandering about, it can tend to degrade timing, and that's really what we're trying to improve upon here. So the main idea here is that the designer selects an image of the desired wiring, and what an image is just basically a layout of the major wires, where the trunks and the spines should go, but nothing greatly detailed. And so then the router takes this image and puts these wires on the net and cleans them by iteratively moving the wires around a bit and checking them for shorts until all the wires have no errors. And this includes same net errors as well, because we just try to keep the vias far enough apart. We keep the wire segments from getting too small, anything that would cause same net error. And so when the router is done with it, the image is completely clean, but it's only of all the main clock wires, and it doesn't include any of the small pin connections, all the details. And so we leave it up to MAR, or one of the many MAR pin connecting utilities, in order to finish the routing. So I'll show how all this works with an example of what you'd see if you ran this tool on SpineNet. So here we have an SCB here at the center. It drives 4 trunk wires out to 4 spines, and the spines then drive all these rib wires out to the sinks. And so this is the image that we pass into the router, and then the router takes that and calls ChipEdit to do the error checking and the cleaning. And so when it first calls ChipEdit, we find that a number of the trunks are in bad locations, and so it moves them around a bit, doing this error checking until it finds good locations for all those trunks. And then it moves on down to the MA spine wires and finds that a couple of the spines are okay where they are right now, but the ones down at the bottom and the robust pin needs to be moved a bit. And so after moving those around, it finds good locations for all these wires. And then finally it moves down to the rib wires, where it finds many problems with the rib wires, but with a few iterations it shifts all those wires into good locations. And so in the end, what you have is pretty much the original image of the spine wiring, but everything's just adjusted until there are no errors. And then finally, we run MAR on this and have it connect all the pins, and then run ChipEdit to remove any antennas, and the net looks like you see here. So this slide just gives a quick overview of the steps involved in image routing, along with some of the associated run times. So creating the image, for example, is very quick. Not hard to do to create all those wires in WSS. And then also adding the robust pin mesh is pretty fast, less than a second. Most of the time, however, is spent in ChipEdit and cleaning up all the wiring errors, and then also in the MAR utilities to make all the sync pin connections. Also note that because we're using ChipEdit to do all the checking, we can do up to 1,500 nets at once. So you're not just doing one net at a time. You can do a lot of massive parallelism here. But then also to move on to CU22, we'll need to add the use of verified connectivity, which is a MAR utility, since ChipEdit won't be around for us in CU22. So this next slide is an example script. I'm not going to go into a lot of detail here, but I wanted to give some flavor for what's involved in running the image router. So there's just a few commands here. The first command just actually creates the spine image on the net. And this next command, the image clean, that actually calls ChipEdit iteratively and removes all the shorts from the wiring. And then this last image pins command is what we use to create the robust pin mesh. And once all that work is done, you have pretty much all the clock wiring on the net. And so then the next thing to do is to call one of the MAR utilities in order to connect to the sync pins. So I'll say in summary that image routing is a simple method for creating clean wiring with straight connections. And it's unlike maze routing, which can wander in order to find a connection. Also, the final routing is very close to the initial image of the wires. We just shift the wires around slightly in order to clean shorts. But in the end of that iteration process, if there are any routing failures that are still shorts left, then the cleaning process will just leave those wires as don't care, so that the designer always has a complete net. And so this is also unlike maze routing, which if it couldn't find a connection through a congested region, it could just leave the wire out completely. And then finally, the router is more interactive, so that the designer can actually help the router by providing a better image in a difficult routing situation. So if there's too much congestion in a particular place, you can actually provide it with a spine that's shifted left or right as a better initial starting point, and you get better routing success this way. And so finally, I'll say that this project is just getting started, but I'm not sure if it will continue, as I'll be leaving IBM at the end of November. So before I leave, I'll be sure to leave the details for how to run these tools in the Project CPR directory. And then also I'll say that if you do use the tool and find it useful and would like to bring me back to have further support and development on it, you can contact my current manager, and Tessin will know how to get in touch with me. So thank you very much for taking the time to take a look at this overview.